Okay, so let's look at the integrated rate law. Okay, consider di mana kamu ada chemical reaction di mana A ni adalah reactant and then you dapat produk. Tak kisahlah produk you apa, tapi kalau let's say benda ni berkaitan dengan order of reaction, you tak pandang dah produk ni, okay? You don't care about what happens to the product. You only care about what happens to the reactant, okay? So, if let's say you punya order of reaction is zero order reaction, this is the integrated rate law for zero order reaction di mana concentration of your reactant, kalau reactant you A lah dia, okay? So concentration of your reactant initial minuskan dengan concentration of your reactant final equals to rate constant times with time, okay? Alright, and then next lah for first order reaction, this is the linear equation for natural log for first order reaction, okay? Di mana natural log concentration of A is equals to natural log concentration of A initial minuskan dengan KT. Alright, for second order reaction, it's gonna be 1 over concentration of your reactant final minuskan dengan 1 over concentration of your reactant initial equals to KT. Alright, but then this is the linear graph method based on the integrated rate law equation. Kalau you susun di dalam y equals to mx plus c for zero order of reaction, if let's say you want to do case the linear graph of zero order reaction, y-axis you mestilah concentration of your reactant, x-axis you ialah time. Kerana you kena build a graph of concentration of your reactant versus with time. Okay, and therefore you akan dapat bila you susun balik this equation mengikut y equals to mx plus c, and you will get that your gradient is actually equals to negative rate constant. Okay, and your y-intercept is going to be concentration of reactant A initial. Alright, so for first order reaction, if you nak buat graph linear, kalau it is y equals to mx plus c, your y-axis for first order reaction must be natural log concentration of your reactant. Okay, and then x-axis mestilah time. Alright, and bila you susun balik this equation mengikut y equals to mx plus c, therefore you will find that your gradient will be equals to negative rate constant k. Alright, and your y-intercept will be natural log concentration of your reactant initial. Okay, next ialah second order reaction. Kalau second order reaction, this is the graph for second order reaction, di mana your y-axis ialah 1 over concentration of your reactant, your x-axis ialah time. Okay, and then bila kita susun balik this equation ikut y equals to mx plus c, and you will get that your gradient will be positive. Okay, positive rate constant. Okay, and then your y-intercept is going to be 1 over concentration of your reactant initial. Let's look at example 1. This example, this soalan Miss ambil daripada soalan tutorial tau. Okay, soalan ini bagi tahu cyclopropane is converted to propene in the gas phase and it's a first order reaction. Okay, so this is cyclopropane, this is your reactant. Reactant you ialah cyclopropane. Okay, cyclopropane. This is your reactant. Okay, buat yang Miss bagi tahu kamu, kalau pasal order of reaction, you will not care about what happened to the product, about propane. Okay, so you jangan pay attention pada propane. Okay, so sekarang you pay attention to cyclopropane. And okay, the key point here, dia bagi tahu this order of reaction ialah first order. Okay, dia bagi tahu first order reaction, and dia dah bagi tahu pun rate constant for this reaction ialah 6.7 times 10 to the power of negative 4 per second. You tengok unit dia pun memang tally dengan first order reaction, which is per unit time per second. Alright, so question A, dibagi initial concentration for the cyclopropane, dia suruh kamu cari final concentration after 8.8 minute. Okay, untuk B pula, dia kata how long will it take for the concentration to decrease from, okay, B pula, dia suruh kamu cari time, tapi dia dah bagi concentration initial dengan final berapa. C pula, dia suruh kamu cari time juga, sebab how long kan. And then, tapi dia bagi dalam bentuk percentage concentration tersebut. So macam mana nak jawab soalan ni? Stay tune. Okay, sebab itulah Miss suruh kamu hafal integrated rate law equation dan juga dia punya graph for zero, first and second order reaction. Okay, sebab kalau you tak hafal macam mana you nak jawab soalan ni kan? Okay, so kalau untuk first order reaction, okay, first order reaction ini adalah dia punya integrated rate law equation. Tapi apa yang kat dalam table ni Miss bagi di dalam bentuk linear. But then if let's say you convertkan dia dalam bentuk ratio, it's gonna be like this, okay? It's gonna be natural log ratio of concentration of your reactant initial to concentration final equals to KT. Okay, ni kan general. Tapi dalam soalan dah bagi tahu dah reaktan kamu cyclopropane. So apa yang you kena buat? You kena tulis let concentration of A is equals to concentration of cyclopropane. Okay? So ni wajib ni kamu buat ni. You jangan pula soalan dah bagi tahu you punya reaktan apa tapi you degil nak juga buat general equation, nanti takut salah. So I want you to please hafal dia punya general equation, and whatever it is you kena faham konsep yang A ni bukanlah A. A ni adalah reaktan. Kalau reaktan tu dah dibagi dalam soalan, you just substitute saja apakah you punya reaktan tersebut. Okay, in this case it is cyclopropane. Alright, so dalam soalan ni dia bagi initial concentration of cyclopropane. So dalam soalan dia bagi kamu, okay, dalam soalan dia bagi kamu concentration of initial for cyclopropane, which is 0.25 molar. And also soalan bagi kamu time dia ialah 8.8 minute. Okay, tetapi your rate constant K is equals to 6.7. Okay, your K is equals to 6.7 times 10 to the power of negative 4 per second. So I want you to look at the unit here. Okay, unit time ni dibagi dalam minit. Tetapi unit untuk rate constant ni dibagi dalam second. So what do you need to do? You kena selaraskan ikut unit rate constant you. Kalau unit rate constant you year, terpaksalah you convert into year. Kalau unit rate constant you second, you kena convert into second. Okay, so time ni dia akan ikut unit rate constant. Alright, so sekarang ni kita dah letkan A tu is equal to cyclopropane. So bolehlah you masukkan dengan happy-nya. Okay, so sekarang ni concentration initial cyclopropane ialah 0.25. So you masukkan 0.25 dekat bahagian ni sebab kat atas ni khas untuk concentration of your reactant initial. Okay, N equals to K. K pun dah dibagi, which is 6.7 times 10 to the power of negative 4 per second. And then kalikan dengan time. Okay, if you look at here, time ni dia change, dia convert into minute. Okay, into minute pula, into second. This time ni dia convert into second. Sebab kenapa? Dia nak kasih sama unit rate constant dengan unit time. Alright, and then after that you dapatlah concentration of cyclopropane yang final ialah 0.18 molar. Okay, kenapa ada unit? Unit pun penting. Unit insist. Okay, unit insist. And then kalau you tak ingat sekalipun unit untuk bracket ni apa, you ingatlah bracket ni menandakan concentration. Concentration is equals to molarity, so unit untuk molarity ialah M besar. Okay, next ialah soalan tanya, how long will it take for the concentration of cyclopropane to decrease daripada 0.25 molar to 0.15 molar? Okay, soalan tanya how long, that means soalan nak kamu cari time. Okay, so sekarang ni bila you dah let A is equals to cyclopropane, so you boleh tahu lah bila cyclopropane tu punya concentration decrease, bermaksud concentration of cyclopropane yang initial ialah 0.25 molar and concentration of cyclopropane final ialah 0.15 molar. And by using this equation, you just masukkan sahaja all the information given and also unit of your rate constant and also your rate constant. Okay, sebab nanti dia akan menentukan. Okay, sebenarnya unit of rate constant akan menentukan unit of your time. Okay, unit of rate constant, okay, akan menentukan unit of time. Kiranya unit of your time akan ikut unit of rate constant. Kalau unit of your rate constant you adalah second, so it's going to be second. Alright. Tapi up to you lah kalau you nak tukar in minute, then you just need to bahagi by 60 je untuk tukar dia kepada minute. Kalau tak, it's already good kalau you leave it as it is sampai S ni sahaja. Okay guys, lastly the question asks, how long will it take to convert 74% of the starting material to propane? Okay, and we know that first order reaction, this is the integrated rate law untuk first order reaction. Sekarang ni kalau dia bagi in percentage, macam mana kamu nak buat? So apa yang you kena buat? You need to assume. Okay, you kena tulis ni, write this down. Okay, assume that, okay, since kita dah buat let ni kan, let concentration yang A ni is equals to cyclopropane, so kita bolehlah free to use it. Okay, so assume that concentration of cyclopropane initial ialah 100, manakala concentration of cyclopropane final ialah 100, minuskan dengan 74 and you will get 26. Okay, so you kena buat this assumption, wajib tulis ni sebelum you nak masukkan all the data here. And after that, bila you dah habis assume yang concentration initial dia 100 and concentration final dia 26, you masukkan saja di dalam integrated rate law equation for the first order reaction. Masukkan dia punya rate constant punya information and also dia punya unit, so that you will know that the unit of time berapa, and you will get the time is equals to 2 times 10 to the power of 3 second. Kalau you tinggalkan sampai sini saja pun dah elok, dah okay. Okay, tapi if let's say you nak tukar in minute, terpulanglah. You boleh bahagikan dengan 60. Alright, let's look at the example 2. Example 2 dia bagi kamu table time, table concentration and table 1 over concentration C4H6. Okay, and this will use the data above to plot a graph of 1 over concentration of C4H6 against time in minute. Okay, kalau kat sini time dia nak minute, ikutlah. You tak perlu tukar in second pun and then B, based on the graph, determine the reaction order and explain your answer. And next, bagi tahu the value of rate constant. Okay. Sebab itulah Miss suruh kamu hafal this table supaya kamu senang nak predict the graph. Okay. Alright, so sekarang ni dia suruh kamu buat graph of 1 over concentration C4H6 versus time in minute. Right. Okay. So sekarang ni based on the graph, you kena tentukan the order of reaction. So you tengoklah order of reaction. Kalau zero order, you kena build graph between concentration of A versus time. Okay. A tu apa? Reactant. Okay, while the first order reaction is going to be natural log concentration of your reactant versus time. While second order reaction, you have to build a graph of 1 over concentration of your reactant versus time, and you akan obtain a one straight line like this. Okay, straight line ni fits to the graph of second order reaction. Lain lah kalau kamu buat 1 over concentration ni lepas tu you dapat graph yang macam ni ke. That means you doing it wrongly. Okay, so Miss nak kamu lukis graf ni atas kertas graf. Okay, teknik untuk kamu melukis kertas graf, you need to penuhkan kertas graf tersebut. Sebab I've seen some of my student, dia lukis graf tu kecil ni je, dia utilisekan. This is y-axis dia, this is x-axis dia, lepas tu dia buat graf tu kecil macam ni je. This is wrong, cannot. Okay, you cannot do graph kecil macam tu. So you kena fully utilize your graph. Okay, so let's say this is your y-axis and then this is your x-axis. Okay, kalau ikutkan your y-axis ni should be 1 over concentration. Tengok ni, unit dia tak tinggal. Okay, unit dia tak tinggal pun. Unit dia ialah per molar. Tengok ni graph ni. Graph ni bagus ni sebab y-axis dia bagi tahu dengan unit sekali. This one x-axis dia bagi tahu dengan unit sekali. Unit dia which is in this case ialah minutes. Alright, and then dia bagi tahu juga tajuk. Okay, title of the graph. Title pun penting kat ia. Dia bagi tahu title of the graph. So the title of the graph in this case ialah graph of 1 over concentration of reactant C4H6 versus time. Okay, so your title should be graph of y-axis versus x-axis. Okay, lepas tu kalau macam ni pun dia pendek sangat graph ni, tak bagus. So kalau you nak lukis balik graph ni, Miss harap kamu stretchkan your x-axis and y-axis. Buat betul-betul. Okay, you stretchkan dia out supaya you dapat graph yang lawa sikit. So I hope that you get this kind of graph lah. Okay, di mana you fully utilisekan your graph paper. Okay, and then one more thing, kat sini kan dia tulis gradient dia equals to rate constant kan. So bila you nak cari gradient, ambil point yang besar-besar sikit ya. So macam ni kalau let's say ada kotak graph ni kan, make sure dia more than 4 something, 1, 2, 3, 4, 5 ke something like that. Nak menunjukkan you buat graph tu memang cantik lah, memang besar lah dia punya gradient pun. Sebab kenapa? Kalau let's say you buat kecil sangat, okay, contohnya this is your graph. For example, this is your graph. Okay, lepas tu you lukis y dengan x-axis, you dah besar dah. Sekali you punya graph tu kecil nonet macam ni. Lepas tu bila you nak buat gradient, you ambil gradient pun kecil ke. So bila you buat macam tu, chance untuk you dapat jawapan yang tepat untuk you punya rate constant ni jadi kurang lah. You punya chance nak dapat jawapan yang betul. Okay, sebab penting tau untuk you lukis graph elok-elok ni. Sebab once you kena lukis graph and then you tak lukis elok-elok, and then you punya rate constant lari, tak dapat markah lah nanti. Okay, so I hope that you follow all of my guidelines in drawing the graph ni supaya nanti tak ada kesilapan yang berlaku. Okay, and supaya nanti you dapat perfect data to find the rate constant. Okay, and next ialah kenapa dia kata kena bagi tahu the order of this reaction. Okay, the order of this reaction is second order reaction because of the linear graph of 1 over concentration of reactant against time that fits perfectly with second order reaction. So that's why kita take this as a second order reaction. So sekarang ni kalau second order reaction, kalau according to y equals to mx plus c, this is how you do it. And we know that kalau this one is gonna be y, k is gonna be m, t is gonna be x. So that's why lah ngam-ngam lah you punya gradient M is equals to X pula. M is equals to K. Okay, so ngam-ngam lah you punya gradient M is equals to rate constant. So, untuk cari rate constant in this case, you need to find the gradient. Ingat lagi tak macam nak cari gradient? Nak cari gradient kan? Y2 minus Y1 over X2 minus X1. Okay, and lastly, when you have obtained your gradient, don't forget the unit of rate constant ya, for second order. Kalau you ingat table yang before this, Miss tunjukkan unit untuk rate constant for second order. Okay, dia punya unit dia ialah per molar per time. Okay, in this case, the time given is in minute. So that's why lah you buat per molar per minute. Ataupun kalau let's say you buat gradient tu, you tahulah gradient ni kan Y over X kan. Y axis you unit dia apa? Per molar. Okay. X axis you unit dia apa? Minute. Okay, so per molar bagi dengan minit, you dah akan dapat apa unit dia? You akan dapat per molar per minute. Okay, lastly, Miss nak cakap pasal half-life yang terlibat dalam order of reaction ni. Okay, half-life ni apa? Half-life ni by definition ialah time yang diperlukan untuk concentration of a reactant ni drop to half of its original value. Itulah maksudnya half-life. So, these are half-life equation untuk zero order, first order and second order reaction respectively. Okay, and these are the graphs that related to half-life, which you kena buat graph of concentration of your reactant versus time. Okay, so these are the graphs for zero order, first order and second order respectively too. Okay, let's look at this example. Dia cakap suruh kamu calculate half-life of radium if 5% of a sample of radium took 2.5 years to decay. Okay, first of all, bila you dapat soalan macam ni, please lah tengok table yang untuk half-life ni, okay. So, when you look at table half-life, if let's say this reaction is actually first order, okay, so you focus lah dekat first order reaction punya half-life equation dia, which is, first order reaction punya half-life equation dia ialah T half is equals to ln 2 over K. So, bila you dah tahu, this is actually the equation for half-life, okay, for first order reaction, which is ln 2 over K. Sekarang ni macam mana dapat K? K tak dibagi dalam soalan. So, you need to find the K. Okay, so you need to find this K. K ni apa? K ni ialah rate constant. Okay. So, macam mana nak cari rate constant? You tahu this is the first order. So, next thing is, you kena bagi tahu integrated rate law for first order. Okay, so this is actually the integrated rate law equation for first order. Okay, please rujuk balik table yang Miss bagi tu. And don't forget to put jangan lupa tulis let A is equals to radium. Okay, you nak letak macam ni pun boleh, ataupun you buat let concentration A ni is equals to radium. So, bila you dah buat let A is equals to radium, okay, so barulah you boleh assume, okay, since that this is in percentage, okay, since that this is in percentage, so you bolehlah buat assumption di mana concentration initial for this reactant radium ni ialah 100, concentration final dia ialah 100 minus 5 is 95, okay. So, the solution dia, you masukkanlah natural log concentration of radium initial is 100. Kat sini you tak perlu risau dah because you dah buat lead ni, so you tak perlu risau dah nak tulis radium banyak-banyak kali. Okay. So sekarang ni you dapatlah you punya rate constant you ialah 0.0205. Okay, so since this is the first order reaction, okay, what is the unit for first order reaction? Unit of rate constant. The unit of rate constant untuk first order reaction, if you look at the table, it is gonna be per second. Tapi sekarang ni, you punya unit time you second ke? Tak, unit time you years. Okay, so it's gonna be per years. Okay, so this is unit untuk your rate constant. Wajib tau tulis unit ni. Okay, and then next, bila you dah figure out the rate constant, barulah you boleh cari half-life. Okay, so untuk cari half-life of the first order reaction, it's gonna be natural log 2 bahagikan dengan your rate constant, which is 0.0205 per years. Okay, sebab you bahagikan benda ni, so daripada ni atas dia jadi years lah. Okay, lagipun unit time kan takkanlah macam time you per second pula. So your T half, okay, therefore your T half is gonna be, T half tu apa? T half tu half life is gonna be 33.78 years. Okay. Alright, just now Miss tunjukkan Halflife Method untuk kalau yang melibatkan calculation. But this one, what if let's say dia melibatkan graph? So bila dia melibatkan graph, you need to do a graph of concentration versus time. Okay, so these are the tables untuk N2O5. Again, kalau pasal order of fraction ni, we actually don't really care much about the product. Okay, so if you look at here, dia hanya bagi kamu concentration of N2O5. So you plot lah a graph of concentration of the reactant N2O5 ni versuskan dengan time in minute. Tak perlu ubah pun in second. Okay, you don't need, you ikut je. Dia bagi minute, you buat minute. Dia bagi years, you buat years. Tugas kamu ialah kamu buat saja graph. Okay, so from the graph, you need to determine the order of reaction. Okay, and then from there, you need to bagi tahu dia punya rate constant apa. Okay, so from this graph kan, apa yang you boleh deducekan from this graph? Yang ni, Miss nak kamu buat atas kertas graph ya. This one, Miss nak kamu buat exercise. Please buat atas kertas graph. Miss nak tengok macam mana kamu dapat. Dapat tak lengkung macam ni? Actually adalah 1-2 point yang you kena ignore supaya you dapat lengkung yang perfect macam ni. Okay, so once you dah dapat lengkung macam ni, you tengoklah, alamak, first order pun melengkung macam ni juga, second order melengkung macam ni juga. So how can you determine the order of fraction by lengkungan yang macam ni? Kalau zero order je yang you akan dapat perfectly straight line. So how? Okay, kalau you nak tahu first order, walaupun you dapat lengkung macam ni, apa yang membezakan first order dengan second order, you tengok, kalau let's say you halfkan you punya concentration tu, sebab apa masuk half-life? Half-life bermaksud concentration tu drop into half kan? So bila concentration tu drop into half, you tengok half-life dia berapa, and then you bahagikan dengan 4 pula. You tengok half-life untuk kalau let's say for quarter berapa. Kalau constant bermaksud dia first order. Kalau second order, kalau you dropkan dia punya concentration by half, you tengok dia punya half-life berapa, and then kalau you bahagikan dengan 4, you tengok dia punya half-life tu mesti dapat 2 kali ganda punya daripada the first half-life. Okay, so if you look at here, dia bagi concentration of N2O5 kan. Okay, so sekarang ni concentration initial untuk N2O5 ni ialah 180. Okay, so you know that silap color. So you know that concentration of initial N2O5 ialah 180 molar. Okay, tapi kalau you halfkan concentration initial N2O5, you will get 90 molar. Okay. So, bila you dapat 90 molar, you tengok dekat graph paper you markkan the 90 and then you kenakan dengan the curve ni and then you bawa turun bawah sebab you nak tahu half-life dia berapa. Okay. So, this is actually the first half-life T1. T1 first half-life bila concentration tu drop into half. Okay. So, you nak tahu T1 ni berapa minit? 20 kena tolakkan dengan kosong. Okay. So, 20 tolak kosong is gonna be 20 minit. So, 20 minit ni ialah masa untuk half-life tu drop into half. Okay, time taken bila dia drop into half. So, ni half-life yang pertama. Okay, the next half-life ialah bila you quarterkan your concentration of N2O5, which now you will get, I believe is 45 lah, 45 molar. Okay, so sekarang ni dekat kertas graph you, want you to markkan 45 molar ni and then you gariskan straight line sampai kita kena curve ni and then bawa turun bawah. So, bila you bawa turun bawah, now your time taken untuk dia drop into half ialah berapa minit? 40 kena tolakkan dengan 20. So, yang T yang ni still lagi lah half-life untuk quarter ni. Tapi 40 kena tolak dengan 20. Okay, so bila 40 tolak dengan 20 dapat berapa? 20 minutes still. Okay, you will still have 20 minit. So, apa yang you boleh deduce kat sini? Dia punya half-life, dia constant. Okay, half-life dia constant from this graph. Sebab ni 20 minit, 20 minit. So, we can deduce that this is actually a first order reaction. Kalau second order, contohnya lah, if let's say, kita tengok kat graph ni lah. Contohnya, you ada 180 initial. Kalau you halfkan, you dapat 90. And then, kalau ni dapat 45, contohnya lah. I tak tahulah, mungkin ni something lah, I don't know. But then, bila you dropkan, contohnya yang ni you dapat 20. Okay, ni 0 sampai 20. Ni tiba-tiba you dapat 40. 40 sebab this is 60. 60 minus 20 dapat 40. So kat sini you tahulah apa tu, half-life yang pertama 20, half-life yang kedua 40. Dua kali ganda. So bila dua kali ganda untuk half-life yang kedua ni, that means it's a second order reaction. But in this case, kalau let's say kamu punya half-life kamu constant, that means it's a first order reaction. Okay. So you tengoklah penerangan dia ni. Based on the graph, since the half-life is constant, okay, macam mana you tahu half-life constant? Sebab you dapat kira T1 is equal to 20 minit for both ni. Ni sampai sini 20 minit. Ni sampai sini pun 20 minit. Okay. And it does not depend on the initial concentration of N2O5. Therefore, the reaction is actually a first order reaction. And the next question, dia suruh kamu cari rate constant kan? So, nak cari rate constant, ingat baliklah Halflife equation untuk first order reaction, which is untuk first order reaction punya half-life T half is equals to natural log 2 bahagikan dengan K. So, bila you nak cari rate constant, you switchkan je lah position your half-life, position half-life you dengan position rate constant you. So, it's going to be K is equals to natural log 2 bahagikan dengan half-life. Half-life dia kita dapat berapa tadi? 20 minit. So, since that you punya unit time you in minute, so your rate constant is going to be 0.03 per minute. Okay, tak perlu ubah unit dia in second. It's already perfect like this. Okay, kalau you ikutkan tengok table of apa tu unit of rate constant pun, you should know that for first order reaction it's going to be per time. Unit untuk rate constant for first order. So it's perfectly fine if you leave it just like this.